A particle moves along a line so that its position at any time t, as long as it's a positive t, because you can't go back in time, is given by this wacky function right here, where s is measured in meters and t is measured in seconds. If you are given a position function, okay, this is called rectilinear motion. If you are given a that's positive, nope, I can keep going, position, I nailed it. The first derivative gives you velocity. The second derivative gives you acceleration. So the first problem is find the instantaneous velocity at any time t. That's just asking what the first derivative is. Okay, so s prime of t is going to be using the power rule and taking the derivative of each and every term up here. The derivative of negative t cubed is negative 3t squared. The derivative of 7t squared is 14t. The derivative of negative 16t is negative 16, and the derivative of 8 is nothing. So that is my instantaneous velocity function at any time t. Nothing to plug in, we're done. B is asking us to find the acceleration at any time t. Similar idea, we're going to take the second derivative, which is the derivative of the first derivative. So we're going to use the power rule a couple times again. The derivative of negative 3t squared is going to be negative 6t. The derivative of 14t is 14, and the derivative of negative 16 is nothing. So that's my acceleration function at any time t. Now, using common sense, the particle is at rest means it's not moving. Okay, so the particle is at rest when your velocity is 0. So let's go back to our velocity function and see what happens when the velocity is 0. Okay, so I'm going to, oh, this is going to be awful. I'm going to set this guy equal to 0 and rip out a negative. So I have 3t squared minus 14t plus 16 and see if I can factor that guy out. Let me see. One of them's got to be 3t minus 8 minus 2. 3t squared minus 6t minus, yeah, that'll work. Oh, how about that? Okay, so that equals 0. Okay. What I need to do is I have two factors here. Okay, the obvious factor is going to be t equals 0, so that's good news. The other one I'm going to set equal to 0 and solve, so 3t minus 8 equals 0 has me adding 8 to both sides, 3t equals 8, divide by 3, t equals 8 over 3. Okay, so one of the things I actually have to really be careful of is if I were to get a negative one of these, that's not possible because t can't be negative. Both of these were positive, so that makes me happy. So the times that these are at rest are actually realistic, legitimate times. And that happens at 2 seconds and 8/3 of a second. Okay, there you have it. Now, displacement of the particle for the first 3 seconds, what does that mean? Well, that just means where is your guy after 3 seconds? Where does it travel? The way you do that is if you were to have like an interval, in our case, interval is from 0 to 3. If I label you A and B, I am finding S of B minus S of A. In other words, where am I at 3 seconds? Where am I at 0 seconds? Subtract the one from the other. Okay, so let's find out what S of B, which is S of 3, is. S of 3 is going to be negative 3 cubed plus 7 3 squared minus 16 3 plus 8. So that's going to be 27. Let's attach a negative to it. 9 times, so that's 9 times 7, which is going to be plus 63 minus 48 plus 8 is going to equal negative 4. So this particle is like 4 feet underground, whatever that means. S of, did I do? Okay, so no, that's not where it starts, though. That's where it ends up. Ooh, close one. S of 0 is going to be much friendlier. S of 0 is going to be 0 plus 0 plus 0 plus 8, which is 8. So I start 8 feet in the air, whatever that means. I end 4 feet underground, which means my total displacement where I am now, or where I started at the beginning to where I am now, is going to be a distance of 12 meters traveled. Ooh. So yeah, lots going on here, but yeah, we did it. I had fun doing it too. I hope you did.